Hello, everyone. Good morning.
Good morning. Morning.
Great. So, hope all of you can hear me well. Are you guys able to access the chat as well?
Yeah, I can.
Okay, great. Perfect. Fine, I guess so. Let's start. It's 9:05. So, if in case people are joining, let them join. So, yeah. So, let's begin. This is Sylvia, and I will be your trainer for this module on big data. I have around 13 years of experience in the industry and work with multiple organizations. And I have started my career as a data warehouse professional and then moved into big data domain. And for the last close to 4 years, I've been taking corporate trainings to different organizations as well as to EdTech platforms. And I do handle one-on-one sessions with multiple professionals as well. And yeah, that's a brief about myself. So we don't have a lot of people with us right now, so it's around 16 so far. So it wouldn't take much time. So I also want to know about you guys, basically your experience, if in case you're working inside the IT industry, and how much experience you have, and what's the technology that you're currently working on. It would be great if you can put this in the chat. If you are somebody who is not into IT yet, who is just exploring, who is working in some other domain, please do mention that as well. Okay. So can we quickly get to know each other? I would want you guys to please mention this on the chat. So just your years of experience and the technology that you're working on, if you belong to IT. If not, what is it that you're currently doing? Okay. This is just to get to know you guys, because if we get to know about the lot, then accordingly we can carry forward the session. Okay. Okay. So we have already somebody who is from the big data domain. 6 years backend developer. Okay. Any freshers here? Non-IT automated. Okay. PLS skill. Great. And just a request from my side. So I would want you guys to stay on mute, because we don't want to have any background noises from any of you. So please do stay on mute. You can ask me any questions at any particular point of time in the chat. But if you feel like, no, you need to talk to explain your question better, just please use a raise hand option. I'll be notified, and then I can call out your name so that you can unmute and talk, so that everybody can experience a pleasant learning. Okay, 8 years in production support and manual testing. Okay, that's great. So as of now, I have whatever you guys have shared, most of you, I mean, almost, I would say 100%. Yeah, there are 2 people who are from non-IT. So yeah, close to 90% of you have been in the industry also, always. So it's 6 years working in manufacturing. Oh, that's great. Python, R, and SQL. Okay. Retail analyst. Okay. Yeah, so certainly a very, very good lot. Okay. Oh, okay. So civil engineer. So that's the very first time you're saying. Great. Okay, so I hope whoever has shared, I have read all of your texts. If you haven't done it, yes, please go ahead and do it. I'll parallel read your text as well. So yes, so good time to start. So let's begin. So as I have seen, most of you are already either from a programming background or I mean, I think few of you are already into the ETL side, so you will have some good idea about big data as well. And few of you are from the analyst background. So let's begin with a very basic question, right? So whoever knows, yeah, you can feel free to post it in the chat. So what do you think big data is? I'm pretty sure you would have heard about it somewhere or the other. Some of your friends might be working, or you yourself might be working related to big data projects. So, what do you think big data is? Just one or two lines from your perspective on what is big data. Okay, transforming huge chunk of unstructured data into structured one. Okay. A part of it, I would say, but that cannot be the ideal understanding of what a big data is. But yes, large data set, okay, volume and variety, okay. I'm sure you would have read the definition of big data somewhere. Large data set, okay, huge value with variety of data. Okay, yeah, that's what huge volume. True, very true. Right? See, the simple thing is the term is not so complex to understand now. It's just basic two English words. It's big data. So ideally, when you hear that word, obviously it gives us an understanding, okay, we are talking about some data which is really huge in size. Right? That's a very first understanding that we do get whenever we see this word, this terminology. Now, the catch is there is so much other than the volume alone, which is generally being hidden just by seeing the term. We cannot understand it. But then please do understand there is much more in big data apart from volume or apart from the size of the data. Right. Now, as most of you have said, it's huge data, the volume is huge, and somebody also said it's huge chunk of unstructured, and I'm looking forward to convert into a structured one or a large data set. Now, how much big enough it has to be in order to be called as big data? Any idea on that? So now we are simply saying in a term like huge or large. So do you think, is there any solid number which says whether a data is big data or not? If not a solid number, probably an approximate number. So basically the question is how much big enough it has to be in order to be referred as big data. Give it a shot. Okay. Any other answers? Billions of rows in CSV. That's interesting. Okay. More than the cluster can handle? No, Nisha, can you just revisit your line? I think more than your system can handle, not the cluster can handle. Right? The moment it becomes a cluster, it's a group of machine, which is what it's going to handle big data. So it's more than your system can handle. Right? Your one single system can handle. Great. If data is from different source, okay. You have to complete that line, Deepak. Data coming from different source. Okay, so let me share my screen. Data coming from different sources like sensors. Okay, got it. TVs or PBs. So Pranjal is saying, so it could be somewhere in TVs or PBs. Fine, let's see that. Okay, let me pull in my other screen. Give me a sec. Okay, so can you give me a quick thumbs up on the chat if you can see my screen? Okay, great. Fine. So now the catch over here is there is no limit as such. I think some of you have mentioned it also. Now there is no solid number, or even there is no approximate number, which can tell you, okay, when your data crosses this, it's going to be big data. Now that's where the challenge is. So now the simple thing is then how I can understand whether a data is big data or not. So now let's start it with a very simple example. Okay. So imagine you're working for an organization. Okay. So you have your laptop. Let's have it a configuration. So let's take it's going to be 32 GB RAM. It's going to be 1 TB hard disk. Let's have it as a quad core. Okay. Now you're working for the organization. This is a configuration of your laptop, and you're working fine, no issues so far. Now you are getting a project, and in that, the data that we need to work on is going to be somewhere on 2.5 TB. So now the immediate thing that comes to you is, no, I cannot handle it in my system. My system is not, the capacity of my system is way lesser than what you have been providing. So what's the immediate solution that we will think of? Go and scale up my system, right? Don't think about any advanced stuff right now. Let's start it from the very basic and beginning. I know you can say like we can upload it in Drive or go to cloud, but let's begin from very basic. So you have this one single system with so and so configuration. The moment the data that you want to work with is beyond your system's capacity, I need to come up with some solution. Right. Now, what are the different possible solutions that I will think of? The very first one, or something that immediately clicks in, would be, why can't I go ahead and increase the configuration of my system? Okay, let's imagine I'm going to increase both of my RAM as well as HD. So I'm going to change it from 1 TB to 5 TB. Now I can comfortably handle it. Agree? I'm going to work with this data. I'm going to do whatever processing it needs, and I'm going to share it with my client. Now the job is done. Happy days, no issues so far. But then after a few days or after a few months, you are getting again another project wherein you are being asked to work with, let's say, around 6 TB of data. Now, again, you are thinking of, okay, days have passed. I think I need to increase the configuration of my system. Let's go ahead and increase. But unfortunately, you found out that you cannot go beyond the 5 TB capacity. The hardware on your system is scalable up to only 5T. Right? Now, this becomes again a challenge for you. Now, either you have to go ahead and purchase a complete new laptop, which has a much more higher capacity. Now, the challenge is I cannot keep on go and increase, or I cannot keep on scale up my system depending upon the huge demands of the data. Now, today I'm getting 60, maybe after a week or so, I might get 80, 10T, and so. Now, this kind of data, which is very high or which is well beyond my single system's capacity, is referred as big data. So initially, when I was having 1 TB hard disk, 2.5 TB was a big data for me because that's way beyond my limit. And when I'm having 5 TB of data, 6 TB of data that comes to me is a big data for me because again, that's way beyond my capacity. So the simple understanding here is It's a relative term, right? Now, for you right now, who is having 5 TB of hard disk, 2.5 TB is not at all a big data for you, right? Because you have increased your configuration. And hence, the definition is purely a relative term. What seems like a big data to me need not necessarily be a big data to you because you might be having a higher configuration than me, right? So then how you can understand whether a data is big data or not, at least to you as a person, when the size is much bigger than your system's configuration, that data is big data. So that's how you can define the threshold of a big data. As there is no solid threshold, it purely depends upon what system that you're working. Is that clear? So this is from a very layman perspective on understanding, okay, what is big data. You don't need to know any complex technical terms here. So when a data comes to you and it is well beyond your capacity, it's going to be addressed as big data. It might be in TBs or GBs or PBs, and it is purely with respect to the single system that you're working. So am I clear, guys? Any questions on this? Great. Now, once you understood, okay, how I can call something as a big data or not, because remember, it's purely a relative term. So, for example, let's say Madhumita. So, whatever seems to be a big data for Madhumita need not be necessarily big data for Anusha. And whatever seems to be big data for Anusha need not be necessarily a big data to Pranjal. So, it purely depends upon your individual system's configuration. Okay, now this is how, in a very simple layman terms, you can understand what is big data. But then there has to be an official definition that can come from any organizations to make it much more clear with some technical perspective, right? Now that's where IBM as an organization, so they have come forward decades back. They have seen this issue as going to be really, I mean, this is going to be a huge issue in the upcoming years, which is basically big data. Now, one more important thing is, I know the size is huge here, right? The size cannot be fit inside one single system. But apart from that, the legacy systems, the legacy processing systems, like your RDBMS, they cannot handle it efficiently. Now, that's where the another challenge comes in. So now RDBMS, we all know, we have used somewhere or the other in our career. So it can comfortably handle all kind of structured data and process it. But then big data cannot be efficiently processed even with these legacy systems. So not only the size, once you receive it, processing them also becomes really challenging. So let's understand what are the challenges and what kind of legacy systems cannot handle this. So let's start with the official definition that is from IBM. So far we have seen a very layman term of definition. So let's see some simple definition from IBM. I'm sure many of you would have heard about it. Have you guys heard about 5 V's of big data? Anyone?
Volume,
Hmm. Yeah, volume, velocity, variety, veracity, and value. No worries. If you haven't heard about it, no issues. Let's see them one by one. Okay. So let's start with the very first V. The very first V talks about velocity. Now, before even getting into this, for people who haven't heard about these 5 V's of big data, don't worry, it's nothing. It's simply we are going to define the term big data with the help of these 5 V's. Now, why I'm calling it as 5 V's? Because these words starts with the letter V uniformly. That's why they call it as 5 V's. So that's why they generally address it as 5 V's of big data. So if somebody needs to know more about big data, or they are just starting their career on big data, they just want to know what is big data, they need to know about these 5 V's. Okay, fine. Let's begin with the very first. So what do we mean by velocity? Simple, speed, right? Now, data need not necessarily be a batch data in order to be addressed as big data. It can come to you at real time also. It can come as a streaming data also. So when the data comes to you at a speed, and the speed is not going to be fixed, it's going to be keep on increasing, which will make the size of the data really huge, then that data can definitely be addressed as big data. So data that comes to you at a varying speed, at a huge speed, which will eventually make the size of the data really huge, those kind of data can definitely be addressed as big data. That's why that's what the very first V denotes. The second V, which is basically variety. Now, what do we mean by variety over here? Now, not necessarily your data has to be structured always. Now, we know 2 decades back, most of the data that we dealt with were of structured format, right? CSVs, Excel. So it can be processed comfortably in an RDBMS, but not necessarily nowadays, right? And hence, big data can either be a structured data or an unstructured data. So unstructured data basically, to combine everything, I call them as all multimedia files, right? All your pictures, your videos, your chat messages, your GIF files, your JPEG files, all of these can be considered as your unstructured or simple bunch of chat messages, the text messages, which does not carry any structure inside. Correct? And also, it can be a semi-structured data, right? For example, like a CSS files, XML files. These kind of files can also be considered as big data. So basically what we are saying is, I'm not setting any limit here. I'm not setting up any threshold that only these kind of data can be referred as big data. It could be of any format. It could be of any type. I can still refer them as big data. The third V, all of us know, volume, right? Which is basically nothing but the size. When the size goes well beyond my capacity, obviously I cannot handle it. I need to refer that as big. Now, this fourth and the fifth V have been recently added. When I say recently, not quite recently, it's been some 6 to 8 years back, it's been added. Now, initially, a decade back, when we want to understand about big data, it is only with the help of the first 3 V's, which is volume, velocity, and variety. But then, based on the ongoing demands of the data, um, the organization want to be much more specific about how you can define big data. That's why this term comes in picture. Any idea on what is veracity, guys? What do we mean by veracity? Trustworthy, consistency, right? Yes, exactly. Quality. Perfect, Pranjal. That's a perfect word. Quality, right? Now I'm going to handle a huge amount of data and I'm going to process them. I'm going to find a way to store them. But then that data need to be of a, a quality because it has to be of showing proper value. I cannot handle a bunch of data, call it as a big data, which does not have any consistency inside it. Then there is no point in processing them at all, right? So make sure the data that you're going to qualify as big data should definitely be a trustworthy data. It has to be a reliable data, right? That's what the fourth V represents, which is an implicit understanding, by the way. But in the recent times, it has been stressed out that we need to make sure big data should also be a trustworthy data. And the final V is basically value. Now, this huge amount of data that you're processing should be generating some business insights at the end of the day, right? What if you are finding a way to store this huge amount of data, right? You're also taking steps to process it. But at the end, if it is not generating any meaning to your business, or if it is not supporting your business, there's no point in doing all of this.
Uh, Hi, I had a question.
Mm,
Yeah, so I had two questions actually. So first is, we talked about consistence under veracity, right?
mm,
So can you explain in what terms we have consistency for unstructured data? And
mm,
plus, one more question is, we discussed that the all the things that are available on the internet, they're not
mm,
necessarily right? So,
mm,
but big
mm,
data also works on stuff like, if we talk in a general basis that
mm,
whatever is like the most common or whatever is the most recurring thing, it kind of finds a pattern there and it gives a conclusion out of that.
mm,
So and if we filter out the data, then also there will be a problem of having less data or prejudiced data. So
mm.
how like does people deal with that, or what is the gray line around this?
Sure, sure. We'll complete value and again I'll come back to your question. Okay, fine. So, what is value as we were talking about? This huge amount of data, please do understand if it is not generating any insights, absolutely there is no point in storing them. So, at any day, whatever data that you're going to address as big data should be generating some insight, should be of meaningful. Now, coming back to what do we mean by consistency and trustworthiness inside your data? Now, of course, there will be outliers in your data. So, if all the data is proper, then most of the data analysts will not be having any job out there, right? Now, certainly there will be outliers. Some of the cases there will not be consistency that will be maintained. Have you guys heard about the term called pre-processing? Right? Or cleansing the data. If in case you guys have attended any of your machine learning classes, you would have heard about that. So there is a term called pre-processing. And if you go and ask any data analyst out there, now we might think they will be doing a lot of they will be writing a lot of codes to process the data, to come up with reports. But most of the time, their job will be inside the data cleansing phase only or in the data pre-processing phase. Because though we are saying like we are expecting a consistency inside your data in order to process them and provide the result in a much better way, practically or in real time there will be some of the outliers which comes to you always, and that's where we do have a lot of pre-processing steps, right? So there is a point beyond which if the outliers cannot be handled, that's when the data becomes of completely waste. I'll give you a few examples. So imagine you're working with the CSV files. Now there is some textual call, right? Now we do have this natural language text processing wherein it can process a text and then it can convert it into meaningful information. What if you are getting some unwanted symbols on the strings, right? Some of you would have already seen it in your data. If in case not, it is basically, see, suppose there is a name, say Sylvia. Now, in between the characters, at times there can be symbols which you can't predict or which is of not meaning to you, right? Now, we do handle a lot of algorithms to trim it off, to cut it off, or to neglect them. But in some business case scenarios, what do we actually have is if your string is coming with any of these unwanted symbols inside it, simply discard it, right? These are some of the approaches of pre-processing your data. So when we say the big data should be of veracity, it should be having consistencies. We are not talking about 100% consistency. I'll be making sure I'm cleansing the data, I'm processing the data, but from the source that they are coming in should be of trustworthy, and it should be I should be able to pre-process them and then further process them down to achieve whatever I want. it cannot be of completely inconsistent, which is what we are saying out here. So obviously, when it is coming from a source, say mainframe or a tandem, or from any other third-party sources, there is a possibility of having some inconsistencies. Well ahead, if you can handle it, great. Go ahead, cleanse it, process it further down. But if you reach to a point wherein you cannot do any of this, the data is completely inconsistent, there's no way that you're going to continue with that, right? That's your first question's answer. The second one that you were asking is finding out a pattern and how we are going to have it here. So that is mostly coming down to your machine learning algorithms, right? If I'm not wrong. So in your machine learning algorithms, you would have handled a lot of big data. We are going to study about Apache Spark also in this module. In that time, there is in Apache Spark itself, there is a component called Spark's Machine Learning Library, wherein we will see how a big data comes with different pattern and how we are going to understand that. Okay, so as of now, the second question, I'm parking it out. So when we come to Spark, we will have much more idea about that.
Okay, thank you.
Great. Codes, what is this? Okay, you guys were answering for that. Great. So any other question on all these 5 V's? Great. Now, what we are seeing so far is basically a problem, right? Which is, I have understood that the data is well beyond my capacity. I don't know how I'm going to handle it. I can understand that it can come from different sources. It should be of consistent. It should be of having business insights, should be generating business insights and all. But what is the solution for this, right? I understood about what is big data, but how we are going to handle it? Now, if you guys have heard about the very old practice of divide and conquer, we can easily understand a way to solve this, right? For example, imagine you're working on a project. You're kind of struggling because you as a single person is working for your project. Now the load is more, so you need to basically do the cleansing process. You need to process them, and you need to generate the reports out also through any of your BI. So ideally, you are a single person who is doing all kinds of work inside your project, starting from gathering the requirements all the way up to generating dashboards, right? Now, if I offer you, okay, you don't have to do all of this alone. Let me give you 3 more team members. So you guys can split the task among yourself and start working on. So all 4 of you are discussing. So what are their strengths and weaknesses based on in which area they are good at? You are actually you're splitting the job between 4 of us. Now, in that way, the work can be done in a much more efficient way. It can be faster, and each one of them can bring in their own expertise also. Right. That's what a simple divide and conquer. Now we can see that in our day-to-day life. We can see in our workplace. Instead of pressurizing or making one person's log, we are dividing the work between multiple. This is a simple approach. Your distributed file system or the solution for your big data is going to follow. Let me quickly give you 2 options. You guys can tell me what are the pros and cons. Okay. So now imagine I'm having 1 TB of data. Nowadays, 1 TB is not a big size of data, but just imagine it's going to be a huge data for you right now. Okay. Now I'm giving you 2 options. Method number 1, method number 2. Method number 1 is basically, I can store this entire 1 TB of data in a single system with certain configurations. Let's not bother on the configuration as of now. A configuration such that it can handle this 1 TB of data comfortably, right? Now I'm also going to give you another approach, which is method number 2, wherein I can store this 1 TB of data in 10 machines. Now all these 10 machines are of same configurations. Whatever configurations they share, it's going to be of same. In the second approach, what you're going to do, this 1 TB, I'm going to split it into 10 portions. Okay. And every portion, I'm going to share it into all the 10 systems. and I'm setting a connectivity between all of these systems. They can communicate among each other. Now, in this approach, what you can do is split this 1 TB of data into 10 portions, store them in all these 10 systems, and establish a connection protocol between all of them. Right. Now, what I could observe in all these methods or in both of these methods is in method number 1, if it takes around X minutes to process, to store this data inside the system completely. Let's not talk about process. As of now, let's talk about only storage. Processing will come a little later. In the method number 2, it's taking around X by 10 minutes plus some delta. Now, why I'm writing this delta? Delta is like let's imagine it's a very negligible number, right? I don't know the number exactly. That's the reason I'm writing it as a delta. But I'm pretty sure that the delta is going to be a negligible number, right? So even if you want, you can ignore, but in order to have a clear understanding, we also should understand that it's not only about X by 10 minutes, plus some delta will also be there. Now tell me which option you can prefer and why. So I've given you both options, how it is going to work, the time it takes also, so that now you can take a decision on method number 1 would be an ideal option for you, or 2 would be an ideal option, and why. So instead of X, probably I can take here is 40 minutes, just a random number. So here it is going to be 4 minutes plus some delta. Let's assume the delta is going to be close to 1 minute. Approximately close to 1 minute, not exactly. Okay, method number 2 option, because it reduces load on one single mission. Okay, perfect. Anybody would like to go ahead with method number 1? Okay, now let's discuss about, because some of you have mentioned it as method number 2. So do you foresee any challenges also? I know in terms of time, it is definitely lesser, but do you see that there can be some challenges as well in method number 2? If so, what are they? Cost of 10 missions. That's perfect, right? Now, I know I can achieve it in a really, in an efficient time, I should say, 1/10 of the time, basically, which is great. But then I need to invest on 10 systems. Yes, that's one challenge, definitely. I mean, of course, it's not a bigger challenge compared to the time efficiency, but certainly it needs to be considered. Data loss may happen. Perfect, Soumya. Right? Cost and technical debt. Yes, exactly. Right? Now, what do we mean by a data loss? Suppose imagine, as somebody rightly said, here I'm having the first portion, second portion, third. Let's imagine I'm going to have 4, 5, 6. Okay. Now, the system where I'm holding my 5th copy, this 1 TB I've split it into 10, right? The 5th copy is residing inside the system, and that system is lost or it's not working right now. Now, there is a possibility, right? At the end, all of these are basic configuration missions. I cannot guarantee that all of these will always be up and working. Now, one or the other mission can go down. Now, even though the remaining 9 portions of data is still intact and active, without this one portion, I cannot say I have the complete data with me. So I will announce that, yeah, there is a data loss happening in method number. Perfect. In fact, that has to be the highest priority, right? Because you cannot lose any data at any cost. So data loss is one very huge challenge. Anything other than data loss, guys? Of course, cost. But then cost is a bearable one, and it's a one-time cost that you're going to deploy. So it is a challenge, certainly, but not to be of higher weightage. We can increase a configuration in M1 and use. Great. That's what we have initially discussed, right, Srinivas? We can increase it, but to what capacity you can increase? There will be a basic threshold which will be available inside the M1's configuration. To that, I can go ahead and do, but then beyond that, I cannot use it. Right? Fine. Now, this data loss, as some of you have mentioned, it's one very huge challenge which we are going to address uh, in the upcoming sessions. We'll see that how we can handle it, how we can address it, right? So as of now, I hope you guys also agree with me. There is method number 1, method number 2. I would prefer method number 2 because it is giving me the efficiency in 1/10 of the time. Now, I told you there is some delta, right? Now, can we see little more about what is a delta? See, remember, all these 10 systems are connected to each other. Correct? Now, somebody said there is a possibility that one or the other system can go down. Also, there has to be a history which needs to be maintained on which portion is stored in which system, right? Now, I know this 1 TB is divided into 10 portions. Now, I need to know the first portion is in which machine, the fifth portion is in which machine, seventh is in which. Now, what I'm going to do in order to handle all of those and also in order to monitor and maintain all the remaining systems, I'm going to create one more system, which I'm going to call as master. What is the job of this guy? He will be monitoring all the remaining 10 machines, which is holding some or the other portion of data. And he will be maintaining the address information of all of these chunks. So implementing this master and transferring the communication from master to all of these other systems, it takes some time, and that time is basically addressed as a delta. Got it. Now this master is going to be monitoring, not only monitoring, it's going to be passing on commands, controls to all these 10 different systems. So the data signal has to come from the master to the systems. Again, it has to go back from the systems to the master. And at situations like data loss, master has to come up with some idea on how we are going to handle it. So for all of this, it needs some time. And that time is basically nothing but your delta. So 1/10 plus this delta. Got it? There is someone's hand raised. Yes, Somya. So does master work as a load balancer as well? Exactly, exactly. Now, as of now, just understand it as master. But then when we come to Spark's architecture, we will learn about something called cluster manager. Right now, I don't want to confuse you to put all of these terms at the very beginning. So as of now, you can imagine the job of your master also as a load balancer, so that all these 10 different systems will share their work equally and parallel processing will be at its best. So to answer your question, it is yes. Got it, Soumya? In between the master and the other systems, there is going to be one more node, which is called cluster manage. But we will understand them in a detailed way a little later. Fine. Now, this divide and conquer is basically nothing but in your regular terms in our day-to-day life, we call this as divide and conquer because we are not pressurizing one single system. We are not going to keep the entire big data inside one single system. Rather, we are going to split it and store. Now, the same approach is what going to be followed when we offer a solution for your big data. What is a solution? It's basically called distributed file system. Have you guys heard this term? Imagine these 4 boxes that I'm drawing here as 4 different systems. They are connected to each other. There is a very generic way to call these. Any idea on what is that term? Whenever we have group of systems that are connected to each other, how do we address them? Have you guys heard about the term?
Cluster.
Exactly, it's cluster. Right? Now, we understood about distributed file system in the previous slide, wherein instead of making one single system do the entire job, what I'm basically going to do, I'm going to split the data, divide and keep it in different machines, assign a node as a master. The master is going to monitor all of this. Now, this whole approach is basically also called as cluster. The structure on how all these nodes are connected to each other, we will be referring them as cluster. And why it is called as a distributed file system? Because the data basically is being distributed across all these nodes. When we are maintaining the data in all of these nodes individually. Right? Now, one such distributed file system approach, which is of really efficient and helps in many industries to solve their big data problem, is Hadoop. Hadoop is one of the distributed file systems. Of course, we do have lot before Hadoop itself. But then why Hadoop is much more prominent compared to all the DFS which came before it? It has a very good edge compared to the different file systems that we had earlier. Now, one of the important edges, it's completely open source. And then another important one is it can be made out of commodity hardware systems. Now, prior to your Hadoop distributed file systems or prior to Hadoop, the Google files, the GFS systems and earlier other distributed file system approach, they demand a very high configuration systems inside the cluster to avoid the data loss, right? Because data loss is a huge challenge. So in order to avoid the data loss, they have a very big requirement, which is all the systems that you're going to deploy inside your cluster should be of higher configurations so that the data loss percentage will be very, very less. Because they don't have a great principle behind fault tolerance. But when Hadoop came in picture, it came as an open source, which was a very big deal because till that time, all of your distributed file systems are licensed, right? So it came as a complete open source. And it is saying like the cluster that you're going to build need not necessarily be having higher end configuration machines. Basic configuration systems like the one that we use for our regular purposes, we can use that as well for building a Hadoop cluster. How it can confidently say that? Because it has a very good fault tolerance in place. What is fault tolerance, guys? Have you guys heard this term? Very, very important terminology in big data world or even in cloud computing. You can go to any of these sector, fault tolerance is one very important area. Basically, it's nothing but recovery. See, imagine somebody said, no, in this previous slide, what if there is a data loss? We all know one of the important challenge here is data loss. And any one of the system which is holding my data is lost, even though I hold the remaining 9 portions with me, just because this one single portion is not with me, I cannot say I have the entire data, right? Now this data loss needs to be addressed. And to address this data loss, we need to have fault tolerance in place. And this fault tolerance can be implemented at its best in your Hadoop's distributed files. Okay, now it comes from Apache as an organization. So probably give me a sec, I'll show you the Apache's Hadoop official website. Just give a sec. Some of you would have already seen it, if not. So this is, just go ahead and Google it out as Apache Hadoop, and you will be getting the very first link, which will be saying as Apache Hadoop.apache.org is their official link. Now, if you go to that page, this is the official page of Hadoop. Now, it comes from an organization, say Apache, so that's why it's Apache Hadoop. And you can find the details on when it gets launched, what are the different components that we have. If you want, you can directly download the bin file over here. The latest version is 3.4.1, but anything on 3 is a stable version. So 3.x itself is stable completely, right? And you can have a documentation for all the latest versions and all this. We are not going to work on Apache Hadoop as such. I'll tell you the reason why we're not going to do. Now, have you guys heard about Spark by any chance? Apache Spark?
Yes.
Yeah. So any idea on what it is? Just some 1 or 2 lines. No worries. See, Spark is also a distributed file system. Now, if you ask me, 1.5 years back, or probably close to 2 years, till the time, in all of my sessions, I have explained completely in and out about Hadoop. Because during that time, I mean, of course, there was some slowness in Hadoop during that time as well, but then I have taken it till for the last 2 years back also. Because Hadoop was still prominent in those days. But now, what happens is, Hadoop started facing a lot of challenges and a lot of disadvantages because of the lot of new demands in the data that we are processing nowadays. Rather, they have come up with another wonderful distributed file system called Apache Spark. Now, please do understand this is also coming from the same organization, and this is also completely open source, which is again a great news for developers. Right? Now, most of the projects which are already work in the industry have been migrated from Apache Hadoops to Spark. Now, that's a simple reason in this course for you guys. The complete lab part is going to be on Spark and not on the Hadoop. But also the challenge is straight away heading into Spark without having any basic knowledge on Hadoop will also be difficult, because you need to migrate projects from Hadoop to Spark. So you should have some basic idea on Hadoop as well. That's the reason how I have planned this session is. So we'll talk about Hadoop, we'll understand about the basic architecture and approach behind Hadoop. And then when it comes to hands-on and lab, we will get into Spark, because that's what's going to help you either to grab a job or to improve your technical expertise.
So
Great.
can we call Spark as a replacement of Hadoop?
Not necessary. See, otherwise I would have said Apache Hadoop is no more, and right now let's only learn about Spark, right? If it has been replaced completely. There are few organizations who are still having it. Probably very soon they'll be migrating them back into Spark. But remember, Spark alone cannot do everything. Now we need to have Hadoop in few places. You guys know, right? We are inside the IT field, wherein not any technology can be permanent, right? It will keep on move. So for that reason, right now Spark is having an upper hand, but we never know. There might be another wonderful distributed file system supporting that particular time's data might come. So we need to know about Hadoop and Spark. So don't think like Hadoop is being 100% replaced by Spark. The day will come, but not right now.
But it is built using the same architecture as Hadoop.
There are differences. There are few architecture approach which are same. So when it comes to MapReduce in Hadoop, the basic hand of Spark is again MapReduce, but then it follows something called in-memory computation, which has its higher. We'll understand all that. Right now, it is too early to talk about all those topics, but you should have an understanding on Hadoop at any day.
Maybe
Okay.
it will clear out when we get to know the difference between these two.
Exactly. Could you please explain the DFS and cluster concept in terms of difference? See, there is no difference as such. Is the name IFE? See, cluster is basically how the infrastructure is, how the support is, how it looks like. This is how it looks like. Any group of machines which are connected to each other. It could be an on-premise cluster, meaning I'm having physically 5, 6 systems. They are all connected to each other. I'll call this as an on-premise cluster. Right? I might be following different distributed file system on top of it, different architecture on top of it. But when we talk about cluster, it is basically like 3 or 4 systems connected to each other based on a protocol. Now, it might be on an on-premise, which is I have the complete infrastructure in hand, or it can be on a cloud wherein I'm hiring few systems from AWS or GCP, and then I'm building a protocol on top of it. Or at times it could be hybrid also, right? So cluster at the end is basically nothing but group of systems connected to each other. On what architecture they are going to work on, that's where your distributed file system comes in place. I might use Google's file system also, or I might use Hadoop's distributed file system, or I might use Spark also, right? So cluster is the structure, and then on what architecture you're going to apply is where DFS comes in. Is it clear, Ifi? How fault tolerance is implemented, we haven't reached that level, Bharti, yet. We have to see. We are just talking about Hadoop, where we understood that it supports fault tolerance. How it is going to, you will learn in a while. Fine. Now this Hadoop as a framework has been divided into 2 major components. One is called HDFS and another is your MapReduce. HDFS, as you see, stands for Hadoop Distributed File System. And this architecture, so it basically has 2 layers. So when you download Hadoop, remember the site I showed you, you download the bin file over there. You have it installed on your system. It basically set up 2 layers on top of your hard disk. The bottommost layer is HDFS, which is responsible for storing. On top of HDFS, we have another layer called MR, which is responsible for processing. Both follows 2 different approaches in order to handle the data. Right? Now, HDFS is a distributed file system which follows an approach called block processing. Now, what I mean by block processing, simple. Imagine I'm getting an 100 GB file to process. I'm going to divide this 100 GB file into 10 GB. 10 files of size, 10 GB each, right? Now, every single 10 GB, you will be calling it as a block. So the single file will be divided into n number of blocks. Now, every single block is basically nothing but a chunk of data, a portion of data. MapReduce is basically an approach which sits on top of this HDFS. So here is where I will store the data using some architectural approach. And on top of that, the MR will read this data and we will process it. So imagine in a healthcare domain, you have a bunch of patients' records with you. Now you need to process them. So you need to understand what kind of, what is a percentage of patients that are recurring and what are the one-time visit patients. So you need to do a lot of analysis on top of it. So for that, we need to basically process this underlying data. So who will do that? Which architectural approach will do that? MR is responsible for. So basically, when we say Hadoop, it basically consists of these 2 layers. One is for your storage and another one is basically for your processing. Now, the important thing over here is, okay, I'm saying like I'm going to receive a file. I'm going to divide it into blocks. But who will decide how many number of blocks I have to create? One second. So multiple commodity hardware means machines with higher config and lower config. Both can, yeah. See, when I say commodity hardware, I means basic cheaper hardwares. If you're opting for a higher end configuration machines, that is your take, right? But I can do my job really well even with the lower configuration systems. You got it, Soumya? My basic requirement is give me a lower configuration system. I will do a better job with that because I have fault tolerance in place. But if you are offering a higher configuration machines, good for you.
Okay, got it.
Yeah. Now let's talk about this block, which is quite important. Why only this specific area? I just want you guys to understand from the Hadoop perspective is because this same block concept is going to come on your Spark also. So when we start writing codes over there, we should have a better understanding on what is block. So let's start that understanding from here itself. Now, as you know, the major version right now we have is 3. Of course, we do have 3.x. 3.4 is the latest. When we were having the very first version, a single block is of size 64 MB. For example, if a file comes to me, I'm going to divide it into certain blocks. Every block should be of 64 MB. But that was in version 1. Version 1 is completely obsolete. Somebody asked, no, can I say Hadoop is replaced by Spark? No, but you can very well say Hadoop version 1 is completely replaced by 2 and 3 because it's no more in use. But in version 2 and 3, the size of one single block is going to be 128. So as a simple math, suppose I am receiving a file of size 256 MB, 256 upon 128 MB will give me 2 blocks. So whenever I receive a file of this size, just go ahead and divide it with the default block size. You will end up in achieving how many number of blocks are needed for the file of size 256. Now, any file that comes to you, the very first thing your Hadoop cluster will do. Now, remember, none of these is going to be happening from the developer side. You will be just providing the file to your Hadoop cluster. Internally, the cluster will understand the size of the file, divide it with the default block size, and come up with the how many number of blocks we need to generate. Now, this block size is a configurable number. Not necessarily it has to be 128 always in version 2 and 3. You can even increase the size. Right? I can even set it up to 1 GB, 2 GB also. Now, any idea when you will increase your block size to, let's say, 2 GB? I'm saying the default number is 128 MB. But do we have a requirement to increase it into 2 GB? If so, at what time? When we will be having a need to do that? Exactly. Exactly, Shraddha, right? At the time of processing huge records. Now, why so? See, suppose imagine I'm giving you 256 MB only. Sorry, 256 GB. And you're still maintaining a default block size of 128 MB. I will end up in generating too many blocks. When I have too many blocks, I will unnecessarily move the data between all of the different systems that are there inside my cluster. I don't want to do too much of back and forth traffic. Right? So to avoid that, when we start working with huge sized files, it is always a good practice to increase the default block size. So it will end up in getting lesser number of blocks. Simple math. Block size, and these are inversely proportional. Correct? So huge block size leads to lesser number of blocks, which is what we have been talking about right now in your disk. And that will make the operations much faster and easy. So don't have 128 MB always. Depending on the size of data that you're going to work with, You can change it. Now, how you can change it? Of course, it needs to be done at the initialization level itself. Now, there are profiles, say big data admin. These guys will take care of that. So there are some XML files, installation files are available. Now, inside that, you have to go and make a change to your block size parameter. Once you change it and you restart, the new block size will be effective in place. Okay, clear on what is block size? Perfect, Shraddha. Yes, your answer is perfectly right. Then the block size can be in term, yeah, very well. That's the reason I told you 1 GB or 2 GB. It depends upon the size. See, imagine the average size of data that you're dealing is in TBs or in PBs. Having a block size in MB cannot support you, right? Does it still makes 3 copies of data like it used to do in version? Yeah, Pranjal. Again, the copy is a replication factor. If that is what you're talking about, it's a configurable number. You can change it.
Yes. Okay.
Okay. Hope block size is clear. Any questions, guys?
I don't know if I missed it, but are there any advantages of having smaller block sizes?
Just think, no. So imagine I'm going to give you, let's talk a very small size file, 100 MB. Okay. Now I'm going to ask you, okay, what is the average size of a block that you want to create for a 3 slave node system? This is your cluster size. There is 4 nodes, but 3 nodes are ideally responsible for holding up the data. And you are having in 100 MB files. So what is the average size of blocks that you can adopt here?
33 point something.
Yes. So what you're basically doing here, you're doing a simple math of dividing it, right? So the basic thing here is, what if I'm going to tell you, let's divide it into 5 MB blocks. So will you agree for that? What will happen if you go ahead and divide them by 5 MB blocks?
There will be 20 needed for.
Yeah, you will end up in having 20 blocks. And how many systems I am having? 3 systems. I need to accommodate all these 20 blocks inside these 3 systems. Now, if in case there are processing going to happen, which involves reading between the systems n number of time, I know there might be n number of blocks stored inside one single systems, but don't you think we will do too much of discretes there? Because a number of blocks is higher?
Possibly.
Obviously, right? See, you are having, let's imagine every single system is going to be having approximately 20 or 25 blocks inside it. To read all of them, every time I'm going to do a discrete, which will ideally slow down your performance. So
Yeah.
having a small size blocks at any day will not help you if the size of your file is really huge. If the size of your file is going to be just 10 MB, having a 5 MB block is a very good option, but
Okay.
not necessarily if it is of 100 MB. So there is some algorithm behind fixing up this number. We will not randomly come up with a number like this. So there is a formula, there is an algorithm. Based on that only, we will come up with a conclusion on what can be an ideal block size.
Okay. So is it like the more size the better, or is there an optimum number like?
More size is always better at any day.
Okay.
At any day, more size is always better. But then again, that's the reason I'm saying it's not just like a random number that I wish for. It's going to be adopted inside the algorithm, and based on that, it will be picking up what can be your ideal block size. Great. So we spoke about what is Hadoop, and we understood about what is HDFS and what is MAR, and we understood about what is block size, why we need to know about block size. Now, the good part is I don't have to do any job of splitting the data and keeping them in node 1, node 2, node 5, node 10. No, all I need to do is just redirect the link to the file. The Hadoop cluster will take care of the responsibility of reading the file, understanding the size of the file, dividing it with the default block size, splitting it into n number of portions, storing every such block inside every such node that we are having. Right. As a developer, your job stops in redirecting the file to your Hadoop cluster. Everything else will be taken care by the cluster at the back. Right. Now, there are few daemons or background processes that we need to be aware of when it comes to Hadoop, because these background processes do comes in your Spark cluster also. Right. Now let's understand what are they. Now, what do we mean by daemons or background processor? First of all, here, in order to make a cluster up and running, it's not just like switching on all those systems and establishing a protocol. Rather, we need to trigger some services so that the cluster will always be active and it will always be running. Now, what do we mean by that? Imagine I'm starting a Hadoop cluster. Imagine I'm holding a Hadoop cluster of 5 systems with me. Okay. So what that means is, so I have 4 systems which are responsible for holding the data. I have one master system which is going to monitor all of this. Now, when I say I'm going to have a Hadoop cluster, initially imagine I have 5 different systems. I'm setting up a protocol between them. I'm downloading Hadoop inside all of these systems. And after downloading, I'm configuring this as master. The nodes which are responsible for holding the data, we will be addressing them as slave nodes because they are doing the job as expected. So I'm going to address them as slave 1, slave 2, 3, and 4. Now, once I install Hadoop and configure them with their respective names on the cluster, they are ready to start the processing approach of your Hadoop. Now, how I will trigger it? Now, I need to start some of the background processes so that they will be always active. They will be looking out for a file. And when a file comes, they will do the block processing, right? Now, in order to do that, I need to trigger some of the services or I need to start some of the services. Now, what are these services? Now, before understanding about the services, you need to know one very important point. The entire approach of Hadoop is built on Java as a language. Like how the systems should communicate with each other, how they should transfer the data, how they should process the data inside it, what happens when something goes fail. Right? All of these logics and the strategies have been written in Java as a programming language. So in Java, there are 4 main services I'm writing with respect to Hadoop. Now, those 4 main services, of course, there are few other services, but we don't generally call them as background processes because they will always be not running. Rather, these 4 services that you are seeing here, they will always be up and run from the moment you switch on or the moment you start your cluster, which is called name node, data node, resource manager, and node. I'm not going to call them anymore as job or task tracker. Many people do remember by the names job tracker and task tracker because that's quite popular in version 1. But then starting version 2, they have changed the naming terminology to resource manager and node manager. Now, all these 4 services like name node, data node, resource manager, node manager, all these are nothing but bunch of compiled Java codes. And what is written inside it? What they are intended to do, those services are written as a code inside all of these services. For example, name node and data node, they are purely responsible for storing. Now, what do we mean by storing? What are the tasks that include? Read the file, right? Split the file into blocks, store the blocks inside different slave nodes. Now, these bunch of jobs will be taken care under the storage area. And that will be taken care by these 2 services called name node and data node. Similarly, resource manager and node manager, they fall under processing. And what do we do in processing? I will read the blocks. I will apply whatever program I want to do. I will collect all the results, the output results. I will merge them together and give you the output. As a high level, I'm telling you, we will understand about MapReduce. During that time, we can break this down and see it in a very clear manner. But right now, when I say processing, it's basically reading the block, applying the logic on every block, calculating the output, merging all the output, and getting the answer. So for the storage related services, we have name node and data node. For processing related services, we have resource manager and node manager as a service. And remember, all these are written in Java. That does not ideally mean that you need to be a Java programmer in order to work with Hadoop. I mean, that was the case initially when Hadoop initially came in picture. Uh, Only Java developers have scope to work inside Hadoop. But then we have Pig came in picture, we have Hive came in picture, where even with SQL knowledge, you can still work on Hadoop. So don't think like when I say it has been built on Java, you should be having complete idea on Java in order to work with this. It's an added advantage. Nobody can deny that fact, but uh, without the knowledge on Java also, we can still be a Hadoop developer. Okay, so clear on what are these background processes? Any questions? These daemons will run in masters and slave. That's a very good question, Deepak. So I'm mentioning here two services, right? One is name node and one is data. Now the catch here is one of these service will work in the master because master is also responsible for storage and slave is also responsible for storage. So if you see this workflow picture, can you find name node is sitting under the master node? This is your master, right? And these are my slave nodes. We know NN and DN are responsible for storage. And can you find NN in the master and DN in the slaves? Which means they split the job among each other. The name node service will be related to storage, but it is running on the master node. And data node is a service which is sitting under the slave systems. They are again bunch of compiled Java codes. That's it. Which takes care of what needs to be done in different scenarios. Now, similarly, your resource manager, which is nothing but your job tracker, sits on the master node. Task tracker, which is nothing but your node manager, is sitting under the slave nodes. So these services are running in both master and slave. Got it? Fine. It's a background process. I'll come to this workflow, but tell me whether the background processes are clear first. Any doubts or any questions on this?
So I have question.
Mm.
So I understood the explanation you gave. Like you have Hadoop, under Hadoop you have the storage, which is the HDFS, and you have the map
Yes.
processing. So this daemon, Hadoop daemons,
Mm.
what exactly like, because I'm seeing here is their background process. So do they run, because I'm seeing you explaining, you are still using them on the HDFS distribution file system. So you still use it on the map process?
Sure. See, these services, they are going to be used in both the processes, both of your HDFS and your MapReduce. Remember, HDFS is meant for storage, right? And MR is meant for, the architectural approach of MR is meant basically for processing. And what I'm saying here, these two are responsible for your storage, right? And these two are responsible for your processing.
Okay, all right.
So basically, internally, it simply means name node and data node are used in HDFS layer, and resource manager and node manager are used in mRNA.
Thank
It's clear now, right? And don't think, okay, I'll only understand HDFS or I'll only understand MR. No, it's together is basically nothing but Hadoop. So, of course, when we are learning, what we are basically doing is we are splitting it and learning to have a better understanding on what is happening inside. But when you address it as Hadoop, it includes HDFS and MapReduce. It includes name node, data node, resource manager, and node manager. So together, all of these four services is what we need to address as the multiple services running in your Hadoop cluster. It will be always be up and running, just that they split the job between the two as storage and process. And it's not like, okay, whenever the storage services are running, processing services are ideal. No. See, your cluster is not meant for handling only one single file. In your cluster, there might be hundreds of files. Few files will come for your storage. Parallelly, few files will be undergoing some of the processing approach. So all these services should always be up and running. It's not like, okay, for the first 10 minutes, I will be only storage. Then the next 10 minutes, I will, no, it always goes hand in hand because storage will also happen, processing will also happen parallelly at the same time. Fine. Now let's understand this workflow. This is very, very important workflow. And by the end of this workflow, you will have a better understanding on how a distributed file system with fault tolerance will be active. Because the same workflow is going to be deployed on your Spark cluster also. And also remember, Spark cluster can also read from Hadoop cluster. That's also another approach. But I'm not going to explain that in deep right now. But remember, Spark can also read from Hadoop, which is basically from the HDFS layer. That is also possible. So we need to understand the HDFS workflow anyways. So let's see how it goes. Now, as you see here, I'm having a 5-node cluster. Okay, wherein 1 master and 4 slave nodes. Now, I've been telling you guys about something called fault tolerance, right? Now, this fault tolerance was not initially active in the version 1. In fact, there was no fault tolerance in place in version 1, which makes it so vulnerable. And that's the reason it was obsolete right now. None of the organization is using version 1 of Hadoop because it does not support fault tolerance. But starting from version 2 and 3, they have come up with different approaches or greater approaches towards fault tolerance. Now, there are so many approaches, but then let me give you 2 very important ones, which will, of course, consolidate all of the remaining services of fault tolerance. Now, the first one under your fault tolerance is called replication factor. Very important. Even again, I'm repeating it multiple times because I just want to stress the fact that this is important. Not just in Spark cluster. Suppose you're going to work on AWS or you're going to work on multiple cloud service providers like Azure or Google Cloud Platform. In all of them, they do have the concept of replication factors. And the second one is name node high availability. We call in short as HA, which is high availability. We'll come to NNHA a little later. Let's first discuss about replication. What do I mean by replication factor? If I want to explain in one single word, it is basically backup. That's it. I know I have a file. That file has been divided into 10 blocks. I'm going to store those 10 blocks in 10 different systems. What if one system which is holding one block of the file is lost? The data is lost. Rather, I am telling you, no, don't have only one copy of all these 10 blocks in your system. Rather, have two copy of every single block inside these systems. So you have 10 blocks, including the replication factor, it will become 20 blocks, 10 into 2. So even if one copy which is sitting inside one single system is lost, you have the other copy on the other system. So there is a higher chance that you can retrieve the file safely, even though if one copy of a block is lost. Now, how many number of such copies? See, I'm randomly giving you a number here as 2. But what Hadoop suggests here is the default replication factor Hadoop at any day supports is going to be 3. Again, remember, it's a default number. It can be configurable. I'm having a cluster of 5 nodes, wherein I have 4 nodes to be acting as slave nodes. Then maximum I can have 4 copies at the same time, right? So imagine copy 1 can be here, copy 2 can be here, copy 3, copy 4. What if I say, no, let's have 8 copies? Do you think will that make sense? Observe carefully. I'm having one block. I'm saying let's have a replication factor of 4 for this block because we have 4 slaves. So what you do, copy 1, copy 2 here, copy 3 of that same block. Remember, of the same block, you're having 4 copies. So if this node is lost, you have still 3 more copies. You can retrieve it from any one of the copies. Agree? Yes or no? Clear, guys? Okay, now I am asking you. Okay, can we increase the replicated copy so that I'll have much more opportunities? No, I have a higher percentage of saving it. Why can't I change it from 4 copies to 8 copies? Then what will happen? Copy 5, copy 6, copy 7, copy 8. I'm storing it again. Now, do you think having 2 copies of the same block inside one single node, will that be serving any purpose? I'll repeat, please observe carefully. Having 2 copies of the same block, right? Block number 1. I'm going to have the copy number 1, copy number 5. Both of them belongs to the same block. Will that be making sense in having 2 copies inside one single system?
No.
Absolutely no. Because if the system goes down, both of these copies are down. Ideally, you're simply wasting the memory of your system by keeping 2 copies. Because at any day, if that system goes down, both the copies are going to be down. So what is the ideal replicated copy that I can create for a 4-node slave system? Tell me, do the math and tell me. For a 4 slave node system, what can be the ideal replication factor? 4 at max, right? Because you have 4 systems. So 4 separate copies you can keep. Why 3? You can make use of everything, right? Right, Bharti? I can keep copy 1 here, copy 2 here, copy 3 here, copy 4 here.
4 copies of single block will again
Yes.
make the system like one system is having full of your data. It will be splitted. Your 4 systems will be having 4 all the 4 blocks. It will
Not all the 4 blocks, all the copies of one single block. See, you have, just imagine as of now, you're having only one block in your file. Okay, you're having a file which is having only one copy. Now my block size is 128 MB, right? My file size is also 128 MB. So how many blocks you will have? How many blocks you will have?
one only.
Now I am saying for this one single block, I'm going to create replicated copies. I'm giving you a cluster of size 5, wherein I have 4 slave nodes. So what is a maximum replicated copy you can create for a file of size 128 MB here?
4 copies.
Simple. You can have 3, you can even have 2 also. But then to make the best out of it, I'm going to go up to 4. Anything beyond 4 is an ideal wastage of storage. Agreed on that? Right, guys? Everyone? I'll come to that. As of now, master will not have anything, any block inside it. Master is only responsible for monitoring and maintaining the slave node, guys. Just imagine the industry scenario. You have a project manager, you have individual contributor. At the end, individual contributor will only be writing code, will only be developing your project. Any day, have you seen a project manager sitting and writing codes? No, right? Simple. The name node or the master here is only responsible for monitoring and maintaining. It will not be holding any portion of the block, or it will not be processing any block at all. Only the slave systems will do the job, right? Fine. Coming back now. So hope this is clear. So this is one of a very common interview question too. So I'll just write it down here. Make these stuffs clear. So the max replicated copies will always be lesser, or I'll not write max. Make sure the replication factor is always lesser or equal to the number of slave nodes in a cluster. Can we say like this? See the statement and tell me, is that making sense?
I was thinking you said they have to be equal.
It can be equal or a lesser also. See, when I'm having 4, yes, it is an ideal choice. But having 3, it is still an acceptable factor. So it can either be a lesser or equal, but definitely not higher.
So what
So
happened to the other one that is not backed up?
you mean if you have 3
Yes.
instead of 4? Nothing is going to happen. Your chances of retrieving is little slower. See, I'm saying I'm having a copy 1 here, copy 2, copy 3, copy 4. You imagine this first copy is lost. What is your possibility of retrieving them back? You have still 3 nodes available, right? If in case, imagine you have only 3 copies, you have only 2 more options left. So the possibility of retrieving becomes little lesser if we reduce the number of replication factor to 3 or 2. So you can either have it as 4 or lesser than 4, but don't make it higher than 4. 4 would be an optimal at any day. Having said that.
I think I'm kind of not clear here. So what I understood by the block is that the blocks will have different like they don't have the same file in the system in the block.
No, one file will be divided into block. See, this is one single file. The file will only be divided into block, and these blocks needs to be replicated. It's
Therefore, they
basically,
have the same information.
they'll not have the same information. Your file, you will not be repeating the data, right? So imagine there is 100 lines of text you are having, 100 different lines of text you are having. The data in B1 is not the same as B2. The data in B2 is not same as B3. So you need to separately maintain copies of all these blocks, right?
Yeah, that is what I'm asking. So if you have 4 blocks, 4 data nodes, and we have only 3 copies for them, 3 backups. So what happened to the 4th block?
No, no, no. Don't think in that way. No, you are getting confused. You have 3 blocks. Every block you have to replicate 3 times. The 4th block or the 4th node might not be having any block for this particular file, but this node might be using blocks of some other file. Your cluster can have n number of files, right? So in this scenario, if suppose I'm taking replication factor for this file to be 3, B1 I'm having 3 copies, B2 again I'm having 3 copies, B3 again I'm having 3 copies. And this is one such possibility. If in case I'm not having enough memory to keep all the 3 copies inside this one single node, yeah, B3 can be here also. So who will decide it? Depending upon how much memory is available in every single node, your master will decide and keep all these blocks accordingly. It's not that every block has to be there in one single node. Depending upon the available memory, every single block has to be replicated 3 times. And they will be stored across the different data nodes.
Okay, all right. Thank you.
Is that clear?
Yes, thank you.
Okay. Don't get confused between blocks and files, guys. I know it might be a little confusing initially, but always remember files are only getting divided into blocks. And these blocks are what we are going to replicate. And when we are replicating it, make sure we have to replicate it either lesser or equal to the number of slaves. See, don't think if I set the replication factor to 5, it is going to throw an error, or setting it to 10 in a 5-node cluster, it's going to throw an error. Absolutely not. But that's not the optimized way of keeping the data. Right? Your cluster is not going to throw an error saying, I have only 4 slave nodes. You are asking me to replicate it 8 times. I can't do that. No, there's no error is going to happen. But it's ideally your waste of memory there. It's not an optimized way to keep the data inside your cluster. Okay, fine. Now let's talk it. So far we are talking about one single block. Let's talk it from the perspective of a complete file itself. Now imagine I have a file F. To make it simple, I'm dividing the file into 4 blocks and I'm naming them as A, B, C, D. Okay. So far we are talking about like B1, B2. So now I'm giving a solid name as A, B, and C, D. So the file F is divided into 4 blocks. Right? Now, the default replication factor is what? 3. Now, can you please see this and tell me whether every block is there 3 times or not? Have a look and confirm.
No.
It's not?
The
Which block
second
is not there 3? Which block is not there for 3 times?
I think every block is.
I mean, I meant to say that every block does not contain that A, B, C.
No, not necessarily, right? See, it is not necessarily that you should keep them all together in one single block. It can be in any random order it picked up. At the end, depending on the available memory, I can keep A and B here. See, also remember, I can keep A and B here. I can keep C and D here. All permutation combinations is possible. And I'm not bothered about that also. I can have A here. I can have B here. At the end, I'm okay. It's perfectly fine. As far as I'm having 3 copies of every single blocks inside the cluster, I'm perfectly okay. I don't bother about the combinations, or I don't bother about only A and B should be in the first system, C and D should be in the second system. It's absolutely not an issue. But you should have 3 copies of every single block that we are having inside the file. Got it? See, that's what happens even in your cloud, right? Okay, let's take this example. Now imagine you're uploading something on Google Drive. Okay, I'm giving you an assignment and you are uploading the answer for the assignment on Google Drive and you're sharing the link to me. Now we all know when we upload something in Google Drive, so somewhere out on the Google server, the file is going to be saved. Now, do we need to worry about which server, in which location, in which system, in which drive this file is getting stored? Absolutely not needed for me. All I need is a link so that I can share it to my fellow colleagues. So what I need is I need to upload this file. I don't mind about at the back in the cloud how many blocks this file gets divided, where they get stored, under which system. Absolutely not needed for. But I'm pretty sure that the file has been uploaded and it is safe. And whenever I retrieve it by opening the link, the file will be given back. Okay, hope that's clear. So we have 4 blocks, we have 3 replicated copies, and keeping all the 3 replicated copies on all the available nodes that we have. Great. Now, once the name node sends this file to all of these data nodes by splitting them into different blocks, making sure the replication factor is proper, these slave nodes they will send a heartbeat signal back to them. Now, what is a heartbeat signal? Simple. It's basically a ping message. Or just imagine like a simple chat message that's being communicated between two different systems. What does it heartbeat signal carry? The heartbeat signal will denote the name node. Okay, you have received a heartbeat from S1, which means S1 is up and alive right now. And S1 is holding the blocks A, C, and D of file F. Similarly, every such heartbeat node coming from every single slave node will go to the name node. Name node will receive it. Name node will understand, okay, all these guys are working as expected, and all of them are holding so and so blocks, and we are maintaining the replication factor also. This heartbeat signal will go for every 3 seconds. Every third second, the heartbeat signal has to go so that the name node is aware, okay, this guy is alive and this node is working as expected. Okay, now this is called a happy path scenario, meaning everything is working as expected. Name node is doing its job, data node is doing its job, signal is received perfectly. Name node understand all these guys are working as expected. So clear so far on the happy path scenario? Any questions so far? Will the master, okay, that question I addressed already. C1 slave node will have another backup copy at another node. Yes, yes, Srinivas. Okay, so that's a happy path scenario where the file is split into blocks get replicated. The replicated blocks are stored in different nodes. The data nodes are sending the heartbeat signal back. Name node is understanding, everybody is doing their job. Now comes the negative scenarios. What if this node goes down? Now you guys tell me what will be the immediate impact if a node goes down, if a slave node goes down. What's the very first impact?
The heartbeat signal will not goes to the name node from S1.
Perfect, perfect, right? So the heartbeat signal will not go because it has to go for every third second. Now that this guy is down, there is no heartbeat signal coming up from slave node 1. Now, what is this immediately make your name node to do? Name node will now realize, okay, now since heartbeat is not from S1, the blocks inside inside S1, which is ACD, is also not active, right? What is the default replication factor I need to maintain? 3. But now since this S1 is down, for the blocks A, C, and D, how many replication copies we have? Only 2. Because a third copy or one of the copy inside your S1 is not available now, and hence only for the blocks A, C, and D, right now there are only 2 copies. You see here, 2 A's are only there, 2 D's are only, sorry, 2 C's are only there, and 2 D's are. Now, this should not be the case because at any point of time, name node should maintain the replication factor inside. Now, this situation is called, or this scenario is called under replication. Meaning I'm expected to have 3 copies of all the blocks, but right now I'm only having 2 copies. And these 2 copies are there for the blocks A, C, and D. B is doing a good job. B is not having any issue as of now, but these 3 copies are a challenge. So now name node has to do some action in order to solve this problem of under replication. Now, what is the immediate solution name node will see? Now, it has a complete start of every slave nodes because of the heartbeat signal received from every slave node. It has a complete start rate. Now, it knows which system is having enough memory to keep these blocks A, C, and D inside. Now, let's assume S3 is having enough memory. It could be any random one, but I'm assuming S3 is going to have enough memory. What it will do, the name node will send command to the slave node 3 asking, okay, now you need to maintain 3 more copies along with the existing copies, which is A, C, and D. Now S3 is also having enough memory to keep. S3 accepts it, and S3 is maintaining a copy of A, C, and D along with the existing copies present. Now, once it stores it, this will also send back a heartbeat signal. Now, the heartbeat signal will denote your name node. Okay, I'm holding C, A, B, A, C, D, which is 2 copies of C, 2 copies of A, 1 copy of B and D. Great. Replication factor is satisfied now. It's no more 2. It is 3. Got it? Now, the issue of under replication is solved by maintaining the copies in one more system where we have enough memory available. Now, this can be further advanced one more step. So this is the first thing that you need to understand. So immediately what your name node will do, it will go ahead and identify where you have enough memory. Now, suppose imagine there are 2 systems which are having enough memory available. I'm saying S2 and S3 both are having enough memory. Then you might be having a confusion on, okay, now which one name node will prefer? If there is only one node, okay, let's go ahead and give the task. But 2 nodes are equally saying, yeah, I can handle. Then the name node should understand what are all the different existing copies which are present inside. Suppose imagine ACD itself is present in any one of the system, then there is no point in keeping the new ACD also inside. So it will check, okay, what are the possible combination of blocks which we have. Based on that, it will decide whether to go ahead with S2 or S3. But all these approaches are happening at the back end. You as a developer will not be even aware, or you will not be having any responsibility to predict or to control these kind of data movement. So the under replication scenario has been tackled right now. So I'm having 3 copies of all the blocks. So great, no issues as of now. But the problem is not completely solved. What if this node, which has gone down, has come back again? Now, what I mean by that is, suppose imagine there is an outage activity happening on the system for some 2 hours. So for the 2 hours, this will not be active. The system will not be active. Or a simple power failure. It could be multiple reasons, right? So it could be a power failure, or it could be a simple outage, a maintenance activity, or the system itself has crashed down. Now we are finding a solution. The system again comes back alive. Now the challenge is once the system comes back alive, it will start sending the heartbeat signal with its existing data. Correct? Now tell me how many copies are there for A, C, and D? Once this guy also comes back, S1 also, S3 is also there. Tell me how many copies are there for ACD? Exactly. We have 4 copies right now. I hope everyone is clear. Right? The node which was down is come back alive. Already I'm having 3 copies. Though along with that, 1 more copy is there. Now this is also a challenge. This situation is called over replication. Like how I should not have under replicated copies, I should also be not having over replicated copies. Because over replicated copies means I'm taking more than the enough memory that I need. Right? Now again, name node has to come in picture. So name node automatically understands what is that the calculation is not matching right now. I'm having 4 copies of ACD, but I should only be having 3 copies. Now name node has to either cancel the copies present in S1 or the copies present in S3. Correct. Now, how it is going to take up a decision? Now, that's where an algorithm in name node will be called up or will be triggered up, which is called shortest path. Now, what do you mean by the shortest path algorithm? The time taken to transfer the data between the 2 nodes, it will calculate. For example, imagine any signal from name node to data node here between the slave node 1 and the name node. Imagine it's going to take, let's say, 0.28 seconds. Similarly, between the name node here and slave node 3, let's imagine it's going to take 0.42 seconds. Then it will pick up the node S1 and it will maintain the ACD copies here because it can be communicated faster. And it will ask the node S3 to delete the copies of A, C, and D inside S3. Now, again, I'm tallying it out. I'm not having 4 copies anymore. Rather, I'm having only 3 copies because a node which can be reachable farthest, that has been asked to delete the extra copy. Got it? So both my over replication and my under replication scenarios have been tackled here with the help of your name. Is it clear, guys? Both the scenario, both the under as well as over replication. Any questions?
Yeah, I have
Please ask.
question. It's clear. It's clear, but I have question. I just want to understand. So the copies we have here, they are set. So in trying to like let's say we have on the replication and we want to make a copy or distribute the one that is not the node that is not working. Must it always be as a set? Must it be stored as the same set? Like you have here, S1 is down. So do we the name node need to save it, look for like ACD, or can you store A in S2 and store C in S3 and store D in S4?
That's a very good question. I hope all of you guys are also able to understand. See, the thing is, what she's asking is basically like, okay, I have ACD. There might be a situation where a single node cannot handle the load of all these 3 blocks together. Right? Am I right? That's what your
Yes.
question, right? See, that is also a possibility. That is what I want you guys to understand. See, it's not like, okay, one solution fits all. Now, it depends ideally on that time how much memory is available on every single data node. Your S2 might be having completely free memory, which can comfortably hold ACD together. or your S2 might not be even having even a single memory left to hold even one block. So in that case, what I'll do, I'll completely ignore S2. Rather, I'll go ahead for S3 and S4. Now in S3, it can handle two blocks. Okay, well, go ahead and store A and C there. S4 can handle one. Well, go ahead and store the D block over there. So at run times, all of these happens. And that's where I cannot tell you guarantee that it will always be in S2 or it will always be in S4. Depending upon the availability of the memory, all these blocks will be splitted and stored. But
Okay.
you have to be confirmed that there will be three copies. I don't know whether they are in S1 or S4 or S3, but there will be three copies.
Okay, thank you. And that brings me to my second question, just to understand, because this concept has been giving me headache. Thank you for simplifying it. The
No worries.
the file, like you have a file, the data, the size of the file, the main file is like, let's say 100. Okay, let me use 1000 so that I will get what I'm saying. So, and we have 4 blocks for the same file. So we have memory storage like 250, 250, 200.
Correct.
Okay.
Yes.
So if they are the same size, what my question is, the file, the data information coming at every point in time from this explanation does not necessarily mean have to be 250 at the time.
Yes, yes,
Okay.
exactly. I'll give you another answer for that. See, for example, when I say 1,000, it is going to be, we know it is going to be equally dividable into 4 blocks, each of size 250. But not necessarily always it's going to be an equally divisible number, right? That's what your question is. So what if I'm having, let's say, 1,050? Then what will happen? You will have 4 complete blocks. Imagining 250 is the size of one single block. Okay. So 4 blocks you're completely occupying. What happened to the remaining 50 MB of data? I need a block. But will I be using the entire 250 MB of this block? Do a simple math. Will I be needing a entire 250 MB in this fifth block?
No.
How much I will need?
Only 50.
Only 50 is what I'll need. What will happen to the remaining 200 present in this particular block? That remaining 200 is left out free, which means it can be used for the upcoming files. So I am giving you a complete block of 250 MB because 250 MB is my one single block size. Depending upon your requirement, either consume the entire 250 MB present inside a block, or take only 50, or take 10, or take 30, depend upon the size of the file. Now, the remaining block will be left out, the remaining memory will be left out free. It will not be idle, it will be left out free for upcoming files usage. Now, this is also known as dynamic storage. It's a little advanced area, but yeah, since you asked this question, it follows an approach of dynamic storage, wherein how much ever needed from your block, consume it. So 250 MB is the size of my block, 1050 is the size of my file. Then I will end up in using 5 blocks, where the fifth block will only be consuming 50 MB of data.
So in this the architecture, this design now, what it means is that, let's say we are having a live data coming from maybe e-commerce or from Twitter or from anywhere. So we assume, when we are designing it, we assume or presume that we have this assumption that the maximum file we'll get from data from the file will be 1000. But it's not like optimal. That means we can get like 900 sometime. We can get like 950 sometimes. Is it what it means?
That's what it means. See, it is a streaming data. So that concept is slightly different. So what we are talking about here is a batch data, which means upfront I have the file. I know the size of the file. So dividing them and storing them in blocks becomes quite simple, right? Because you know the size of the file. Based on the size of the file only, you will allocate block. But the example that you're saying, like in a streaming data, wherein you don't know how much size is going to come, maybe max you will have a limit, let's say 1,000 or 2,000. In that time, what happens is every single second you will be getting the data in a particular limit. So you will be having, let's say, 50 Mbps or 30 Mbps. So what is the maximum capacity per second you are getting? 50. Based on that, you will decide the block. So for reading streaming data, the concept is slightly different. Now, the
Okay.
one that we are talking about is only for pure batch data,
That's it.
because
Yeah,
in
okay.
batch data, upfront, I know what is the size of the file,
Okay. All right. Thank you.
correct?
Thank you,
Yeah.
Sam.
Yeah. Streaming data will be slightly different because, see, even in streaming data nowadays, we don't have, in some of the industry-based projects, we don't even know the upper limit also. So there has to be a lot of optimizations happening over there. In that case, architecture will be slightly different. Okay, great. Okay, any other questions, guys? What if S3 time less than, what is this? What if S3? See, wherever your node is lesser. See, I'm taking an example of S1 to be lesser than S3. So I'm sticking up with S1. If S3 time is lesser than S1, obviously I'll stick with S3. No confusion, sir. No. So in worst case scenario, what will master do if there is no memory in S2, S3, S4? Now I want all of you to try to answer to the second question of Ram Srinivas. So his question is, in a worst case scenario, there is no memory available in S2, S3, S4, and S1 is also going down. Now I need to take some action to keep the copies of A, C, D somewhere, but unfortunately S2, S3, S4 all are already full. Now this scenario will not happen in most of the time because we do have a memory control. When you reach a threshold, we will automatically do the scale up. So the solution for your question is scaling up. Now we do have auto scaling feature also in the recent versions of your Hadoop. But basically what do we mean by scaling up is, I can add multiple nodes as possible, which I call it as scaling horizontally, right? Which is nothing but scale out. You are having more missions because the data is keep on increasing. With the existing systems, I can't do anything. Now I need to keep on add more systems. Either you can add more systems or you can increase a configuration of one single system, which is called vertical scale. So vertical and horizontal scaling is possible whenever you reach this. But I'll not completely take the scenario of Ram Srinivas because you will never approach that place of, you will not even reach the place of you're completely exhausting the memory on your own. There is a threshold at any day. Now, when you reach 75% itself, you will be doing the scaling up feature so that no more challenges you will face. Okay. Yeah. Next question is, if system is storing live data, then data from the down system might not be accurate to retrieve or pre-process. So in this case, how it is, that's what I'm saying. This Hadoop cluster, Hadoop architecture is entirely only for batch processing. Hadoop cannot handle real-time or streaming data or live data. Got it, Ram, Srinivas, and Rajesh? Is your questions clear?
This Hadoop system actually, in case of underfitting or something. So
Under replication.
under application. So
Mm.
S3 will have 2 copies of A and 2 copies of C like this, right?
Mm.
So is it feasible enough to keep 2 copies of A? Because once S3 goes
Mm.
down, that 2 copies itself is
Mm. Mm.
not
But
retrievable.
the third copy is also there inside S2, no?
No,
Right?
means I'm just asking that
Mm.
maintaining 2 copies in a single system, will it
Mm.
work? Is it
Yeah.
worthy?
That's a good question, but then the answer lies on the question itself. See, the thing is, I know I can have 3 copies at the max, or 3 is my replication factor. Now, the best case scenario is having 3 copies in 3 individual machines. But in case of failure, I will be forced to keep definitely 2 copies in one of the system. There is no other option because the maximum number of systems you are having is 3. So any ideal scenario, 3 replication factor means always 3 systems should be up and running. But we are talking about negative scenario, which is not going to happen always, right? In a situation wherein one or the other node goes down, definitely 2 copy will be there in one single machine, which you cannot avoid. But a third copy can be in a separate machine. So there is a possibility of still retrieving it from one more machine, but I know 2 copies will be sitting inside one single machine, which is a waste of memory. But you cannot avoid that in a negative scenario, like a machine going down. Right? That's not going to be always happening. In a failure scenario, it happens. 2 copies can be there in one single system, which is very well allowed and possible. Fine. Now there is one more negative scenario which can happen. Can you guys think of it? One more negative, possibly a negative scenario. See, again, remember all these negative scenarios, they're not going to happen very frequently. At the end, your cluster will be having good configurations. The possibility of failure is less, but still, we need to come up with a solution for this. Yeah. What are the other negative scenario? Apart from a data node goes down, apart from a slave node goes down. Think.
What if the name node goes down?
Very good. That's what I've been even asking right now. So the other scenario is basically, how about this guy goes down? Okay, now since you said that, tell me what do you think will be the major impact if the master node goes down? What will be the major impact?
The system will be down.
It basically becomes like a dead cluster. See, I'm approaching this cluster through the master node only. So master is basically the face of my cluster, correct? Can we call that? Because I don't know any detail about which block is in which data node. All I know as a cluster is I can communicate with the master. Master will help me retrieve the data. But now the challenge is master itself is not accessible, which means the cluster itself is completely not accessible. All the data nodes will be working effectively. They will be waiting for commands from master or the name node. But at the end, the name node as a service or the master as a service is completely down, which will make the cluster completely inaccessible. Now, this is one of a very, very critical scenario. Now, if you remember, earlier I mentioned 2 areas under fault tolerance. One is your replication factor. Another one is name node HA, high availability. Now, what do we mean by this name node high availability? While designing the cluster itself, right, while coming up with the cluster itself, I will allocate one more node, okay, which will be of same configuration as this master. I'll call that node as standby name node. And what is the responsibility of this node? This node will also receive the heartbeat signal from every slave. Like how these guys are sending heartbeat signal to the name node, they will also send it to the standby name node. From every node it will come. So, like how your name node is gathering all these heartbeat signal and maintaining it and monitoring all of them, the same way standby name node will also gather all the heartbeat signal, maintain it. But it will be passive. It will not be active. It will be in an idle mode. It will understand the information coming up from the data node, but it will not pass back any commands back to the data node. Rather, this master will be the active one who will be sending commands and messages to all the data nodes. And the standby node and the active name node, both of them will also be connected to each other. So the moment your active name node goes down, immediately your standby name node will also understand, okay, now there is something wrong with the active name node. Now I have to take up the place. So this standby name node, which was in a passive mode, right now become the active. Now, if you have a question on where does it have all the data, because if you want to be an active name node, you need to know the complete stat of all the data node. Remember, the heartbeat signal goes to standby also. So it maintains the complete information of all the data nodes and the different blocks that they are holding. And hence your standby will become active in terms of failure of your active name node. Okay.
Data
And
node always transmits the signals to two name nodes.
they should not be addressed as name nodes. That is standby, and this is the name. This is the active one that is always standby. Only in situation like this, a standby becomes an active.
No, but in order to, in order for the standby to take the place of active, it must be updated, na? So that's why the data
That's
node.
the reason heartbeat signals are going up.
So yeah, that was my original question. So data node is always, always transmits two signals, one to the standby or the other one to the name node.
Yes. That's what we have been discussing. So the thing is, not necessarily there will be only one standby node in place for a cluster. You can have 5 or 6 standby name nodes also, depending upon the budget, depending upon what kind of data, depending upon the severity of the data that you are having inside your cluster. That's why it is called name node high availability. Meaning at any time, the name node has to be highly available. Hence, I cannot be dependent upon one single master node or a name node. I can have as many standby name nodes as possible. But the minimum is going to be one standby node in any Hadoop cluster. So whenever we say we have a 5 node cluster, it means 5 node plus one standby name node cluster. It will only be effective, or it will only be useful in situations of name node going down, but it should always be present inside a Hadoop cluster. Yeah. Any questions? Let me know.
So again, the question goes back to my first part. So if we have multiple standby nodes, so then again the data node, how does data node knows that all these are the standby nodes and only the one is the name node?
It's been configured. No, it's a cluster at any day. How do you define a node? Every node has been configured with a name. There will be an IP associated with it. There will be a name associated. There will be a host name associated with it. So whatever node which is responsible for an active name node, to that it will be sharing the heartbeat signal. Parallelly, it will be sharing to all of the standby name node, but only from the IP which is active. From there, it will be receiving the commands, so the data node will behave according to the command received from it. Every node will have an identifier, like an address. So with that, it can easily be traced out. Okay.
Sylvia, how are these two this master node and the passive node communicating? Again through the heartbeat signal, it's like they are communicating with the data node.
No, they will be communicating with each other, not via the data node. See, you have a separate standby name node here. These two guys should communicate directly with each other, because only when this signal drops down, your standby will understand there is something wrong with your name. So this is again a ping. See, all these are basically ping methods. So if you have learned by any chance Unix, you will know what is a ping. So it's basically like a handshake signal between two different systems, a communication between two different systems. So it is just an, I mean, you can refer them as heartbeat, but at the end, it is basically a ping message between the two different systems. It is only between these two, not via the data.
Right. And the time is again 3 seconds between both of
No,
them?
definitely should be lesser than 3, right? It cannot be 3, because if it is 3 or even beyond than 3, there is a possibility that we will be missing some information. These are configured. If you can go inside the initialization file, we can get to know about the detail. It is generally predictable to be somewhere between 0.75 to 1 second. But again, these data are completely configurable. So I cannot say only this is the number, but somewhere it falls between this time frame.
Okay, yeah.
It
Thank you.
will be much more quicker compared to your heartbeat signal time.
Okay. Thank you.
Can we have more than, yeah, that's what I said, right, Deepak? You can have n number of standby name nodes. See, this feature of name node high availability was not there in version 1. And that's where in your version 1, if Hadoop, I mean, if your master node is down, it's called a SPOF, which means single point of failure. When this guy goes down, just shut down the cluster, go home. You can't do anything. I know the data nodes are working good, but then I don't have a solution for your name node going down. But then in version 2 and 3, we have the high availability, which helps us to recover it fast. And remember one thing, see, it's not an alternative node, Pranjal. So secondary name node is an older service, which is mainly used to maintain the metadata. But then once this new version comes in picture, which is your standby name node comes in picture, there is no need for that. Yeah, I was telling about failures, right? Yeah. So now remember one thing. See, to understand how the internals are working, just give me a second, I'll finish it. It will be great if you guys can raise your hand before you unmute, because it will disrupt the flow when we were talking, and it will be disturbing others who are listening also. So I'm okay if you can unmute and talk, but please do use a raise hand before you do that. Fine. So what I was saying is, yeah, all these failure scenarios, right? Whatever we are talking about, whether a data node goes down or a name node goes down. Now, these situations, they will not be even updated or reflected to you as a consumer who is using the cluster. See, since we are reading all of them, we are studying them in detail, we are understanding what happens when and all those. But then remember, all these happen in a fraction of seconds, which you might not be aware unless and until you open the log and see what happened in every single second. We are not even aware, right? Now, again, I'm taking you to an example of cloud so that everybody can understand. So imagine a Google server located in USA has been has been gone down for some reason. You will still be able to access all your Google Drive, all your files that you have kept inside. Or imagine you have uploaded some files under AWS. Okay. And in the AWS distribution center, imagine there is one complete rack which has gone down, right? But your data is still being accessible. Unless and until that news come back, the news you go and read that news, you are not even aware that there is a server or there is a rack that has been completely down for so and so period of time. So basically, all this happens in a fraction of a second, or all this happens with the recovery in. Now, failure is not a part which you can take out. Failure should always be there, but then the recovery is there in order to control it. So the reason why I'm saying is, don't worry too much about failure scenarios, because all these failure scenarios have been handled with your fault tolerance. Same comes down to your Apache Spark also. And in Apache Spark, it's going to be little more powerful also compared to how we are seeing out here in Hadoop. And it follows a separate approach called in-memory computation, which makes it even more efficient in the way we are processing. Okay, fine. Used to transfer. No. Zookeeper is a gatekeeper service. It's like a watchman service. Checking out what kind of files are coming in, how much memory it is there, how it is going to. It's basically like an admin kind of service. Okay. Yeah, somebody you are asking something. You can talk now.
I have a doubt with name node. So if it is go down, then what is the how we can retrieve the data? It's suppose
That's what we
totally
have.
corrupted. Name node is totally corrupted.
Then
how we can retrieve the data?
Were you there when we were explaining about standby name node?
Yeah, a standby name node.
So standby name node is basically just an alternative to your name node, right? It is receiving all the heartbeat signals from the respective data, which is what I was explaining so far. And name node and standby name nodes communicate with each other. When there is no communication coming from name node, SNN automatically understand, okay, there is a fail over there. I need to take care of the situation. It maintains all the stats of the data node. With that, it starts behaving as an active name.
Okay. Thank you.
Okay, fine, guys. So this is all about your HDFS workflow inside your Hadoop, in your entire Hadoop cluster. When it comes to storage, all these are happening. Now, please understand this is only regarding storage. This is not when it comes to processing. Okay, so just see this. So when it comes to processing, what happens? That is where your map reduce came in picture. Now, what is the approach behind map reduce? Now, again, it's a distributed file system. So we are going to process also, like how you're storing in a distributed file, we are going to process. I'll give a heads up on how it is going to be. See, imagine I have 4 nodes. Okay. And this is the master. This is my slave node. Let's imagine there is a file which is divided into 4 blocks. S1, S2, S3, and S1. Now block B1 is here. Just imagine replicated copies are also there. I'm not writing because you guys are already aware on replication factor. I'm not writing them down here, but that is also there. Now, storage is done. We understood about HDFS. So based on the approach of HDFS, storage is needed. Now I want to process this. See, at any day, if a file comes, it's not only about storage. I also want to process and check out how it performs. Right. Now imagine I'm writing a Python code. Okay. So suppose I'm naming them at process.py. Now I want to apply this Python code on this entire file. But the challenge is it is in a cluster. So I cannot share it to one single system and run the code entirely in a sequential mode. So I want to send it to this cluster because I know the input file is available inside the cluster. So what I'm going to do, I'm going to send the Python code also to the master. Now, since the master is receiving the Python code and it needs to be processed, what is the master service related to MR, guys? Anybody remember the name? What is a master service related to MR, MapReduce? We have seen 2 names.
Resource manager.
Tracker, job tracker.
Yeah, job tracker was an old version name. So right now we are going to call them as resource managers. So no more NN. Going forward, we are talking about MR. So in MR, I need to call it as a resource. And what is a slave service? Anybody remember?
Tax tracker.
What is a version 2 name?
Node manager.
Exactly. So NM, and in short, I'm writing as NM, NM, NM. So again, these are nothing but compiled Java set of codes which will guide on what actions has to be taken whenever a scenario happens. Now, the moment the code comes to the resource manager, okay, what the resource manager will do, it will communicate with the node manager. Please observe this carefully. Remember, both of them are inside the master, right? Now, the resource manager will communicate with the node manager. See, I have to run a code, say process.py, and this needs to be applied on a file F. Now, can you give me the location of the blocks of file F? Then what the name node will do? Sorry, I have written here as node manager. Sorry, guys, this is not node manager. This is name node. Right? Now it will communicate with the name node and it will understand, okay, where these blocks are located. Now the name node will give you the information. Okay, so you are looking for file F. File F has 4 blocks and they are located on S1, S2, S3, and S. Now gathering all this detail, what the resource manager will do, okay, I have 4 blocks residing in 4 systems. What it will do, it will create 4 copies of your Python code. Please observe this carefully. It sends all these 4 copies. It's the same copy of the code. So whatever content is there inside this program, it is copying that and sharing it into all the 4 different systems. Now, the node manager will receive the PY code. It will apply the code on the block B1 and it will generate an output. So obviously, when you apply a code on a data, you will be receiving an output. I know that output is only for block B1, but still I'll receive. Similarly, the node manager will apply the code on block B2. It will also collect output 2, output 3, output 4. Now, this process is basically called map. Now, the entire map reduce approach is basically divided into 2 areas, map and reduce. What do we mean by map? Mapping the program to the block of a file and generating the output. Now, once all 4 blocks have individually generated their output, then comes the second phase, which is reduce phase. What does a reduce phase will do? Okay, now the master will understand, which is a resource manager will understand, okay, all these 4 guys have finished their job. Then what it will do, it will call out any one of these slave nodes and ask it to do the job of reducing. So for example, marking another car. Let's imagine the resource manager has picked up S3 as a guy who can do the job of reducing. How it will select? Obviously based on the available RAM space because it needs to process. Now what the S3 will do, it will collect all the intermediate output. Now, what are intermediate output? OP1, OP2. Why I'm calling them as an intermediate output? Because they are not the final output. They are outputs of individual blocks, which further needs to be consolidated. Hence, I call them as intermediate output. Now, these intermediate outputs will go to the S3, and now S3 will do the job of consolidation. You know what I mean by consolidation? I'll combine all these outputs and generate one final output for the entire program on the entire file. This part is called reducing, because you're reducing multiple output into one single output for your file. Now, together these two approaches forms your map reduce processing. So the first phase is map, wherein the code is mapped out to the block and the output gets generated. Second phase is all these intermediate outputs are collected, consolidated, merged, and one single output is generated. Is it clear?
No, not clear.
Which area you are finding it difficult?
So I am sorry to pull you back, to drag you back. So when the code is sent, like Python code is sent from to the resource manager, I need to query any of the block or the files in any of the block. Then the name node is sending the same code to all the blocks, right?
Not the name node. Is name node's responsibility is to sending the code?
That's what I'm saying. It will send it the same code from the resource manager to all
No.
the blocks.
What does a name node window? See, resource manager as a service, it is only meant for processing.
Yes.
It will not know where a particular file's blocks are located. Who will know the file to block related information?
The name node.
So it has to communicate with the name node in order to understand that. So that's why it will communicate with the name node. See, I need to apply this code on a file F. Can you give the details of file F? So that details will be shared by name node to the resource manager, saying F is there in B1, B2, B3, B4 on S1, S2, S3, S4. Then the resource manager now will understand, okay, I have 4 blocks. So I need to operate all the 4 blocks separately, right? So it generates 4 copies because resource manager is responsible for processing. So it generates 4 copies, share it to all the nodes where you have all the 4 blocks available. Then the processing kicks in. Now, every single slave node will have its own RAM, will have its own processing power. At the end, it is just a node which has its own configuration. It has its own RAM. So the node manager will do the job of processing the particular file, particular block which is there inside it, and generates the output. So clear on that? So individual outputs you have gathered, right? Why 4 outputs you are capturing here?
Because of the files. Each file are in different blocks, the same file.
The file is basically having 4 blocks. So that's why 4 outputs. Simple as that. You're not creating, remember, sometimes I have got this answer is, I get 12 copies. Why 12 copies? People do think you are having a replication factor of 3. So every copy I need to process. Not needed. You don't have to process that same block again and again. You process that one single block, one single time. You get the output. Got it? So 4 blocks, 4 intermediate outputs, map phase is done. Then kicks in the reduce phase, where any one of the node will do the job of consolidation and generate the final output.
So what, let's say you have, I just want to understand this once and for all. Let's say you have, using a case study, we have a file that have maybe customer details information. So we have, does it mean in batch A, block 1, we have, we want to query, we want to get the customer's name and location, let's say, right? So does it mean that each of the intermediate outputs will be customer name and location, customer name and location, the same customer name, the same customer location? Then the reduction will be to reduce it. Like if you have a duplicate of one customer 3 times, you will just use one. Is that what it means?
Yes, when you're reducing it, obviously it's going to be compressed and we will be getting one single value at the end. See, for example, let's take a simple scenario. You are taking customer name and location, right? So I'm just imagining the same thing, customer name and location. Here, let's say A, he's from a location, let's say Bangalore. It's in India, it's a city. So again, in B, it's there in Mumbai. Now, here there is another block, right? Now here there is again one more customer C who is coming from Bangalore. Again, D is coming from, let's say, Hyderabad. So these are different cities in India. Okay. So again, that is E who is again coming from Bangalore. It's coming from F again from Delhi. And G who is coming from Delhi. And H is again another customer who is coming from Chennai, right? Now, I just want to know how many customers are coming from every single location. What you will do? You tell me. In Bangalore, there is one customer as of block 1. In Mumbai, there is one customer in as of block 1. Right? I feel.
Yes.
So in B2, from Bangalore, how many customers you are having?
1.
Hyderabad, you are having 1. Similarly, all of these you will do. Finally, when you do the job of consolidation, all these ones, don't you think you will add and you will finally get, okay, there are 3 people coming from Bangalore.
Okay, all right. Okay.
In Mumbai, after I consolidation, there is only 1 person. In Hyderabad, there is only 1 person. In Delhi, there is only 1 person. In Chennai, there is only 1 person. So at the end, all these individual outputs I'll consolidate and I'll get the final.
So this is just like a summary.
So it's basically, instead of doing the entire thing in one system, I'm doing the same job but separately, and then I'm grouping them out, just like a summary.
Okay. Just like a pivot table in Excel.
Exactly.
All
You
right.
can take it in that way also. But of course, there are few unique behaviors here compared to that. But yeah, on a very high level, you can understand it in that.
Thank you. Thank you so much.
No worries. Yeah. How about others? Is it clear, guys?
I have a question. Like, let's suppose, so we have thousands of name nodes.
Thousands of name node itself. Okay.
And let's suppose one of our file needs 2 blocks only. Needs 2 blocks and 2 name nodes, two different name nodes. So will the master will send signal to every name node, thousands of name nodes, and get to the fact that the file is present in 2 name nodes only, or how does it work?
No, first of all, file itself will not be present in name node. File will only be present in the data node. You have to be clear on that. Name node, at the end, there will be only one active name. If you are saying 1,000, let's imagine the example that you're saying. You are having one name node here. I'm going to have, see, when you go into very bigger organizations, there can be multiple active name nodes also, but then they are for different domains. For example, for purchasing related data, they will have one name node and 100 data nodes. For shipping related data, maintaining all of them, they'll have a separate name node. Now, every such name node internally will have standby name nodes also. That's a very big scale up level cluster. So inside your purchasing category, if suppose you have one file which is of having just 2 blocks, the purchasing category name node is having, let's imagine, 5 standby name nodes. Now these 2 blocks residing on the 2 different data nodes under the purchasing category must share their heartbeat signal to all the standby name nodes, whether it is 5 or 100 or 1,000 or 5,000, they have to share their heartbeat signals to all of them. But to whom they will respond? To only one single name node, they will respond. But the heartbeat signal will go to all of them, all the standby name nodes.
So actually, my question was, suppose, so let's suppose there are thousands of data nodes and one name node only. So, and the actual file resides in two blocks of two data nodes. So, will my name node will send the Python signal to all the thousand nodes and get to know that my file resides in two data nodes only, or
No, why so? Why so?
any
Every data node is sending heartbeat to the name node, that you are aware, right?
Correct.
So only these two nodes will send the information to the name node saying I'm holding block 1, block 2 of this particular file. Will the data node 3 all the way up to 1000, will they be sharing anything related to the file?
No.
Then why I have to send signal to all the remaining nodes? Because I'm already aware that only among the 1000 data nodes I'm having, only two guys are having the related data. The remaining, how much? 998, they are not having any data related to this particular file. This name node is well aware, no? Then why we have to send signals to all the 1000? Got it? Depending upon your heartbeat signal, your name node is very well aware who is having the data, who is not having the data. So why unnecessarily you have to send the message to, or unnecessarily send the code to all the thousands which are not even a part of the file?
Basically, to know that these two blocks are having the data, so we need to send signal to all the thousands, right? That do you have that file or not?
No, that's what I'm saying, Bharti. See, I'm telling you, see, I'm having the blog. I'm having the blog. Imagine these two guys are having the blog. B1 and B2 are having the blog. So they will only share the information to the name node. See, I'm holding B1, I'm holding B2. Tell me, will these two guys say anything related to this file? S3 and S4, do they even send heartbeat message, anything related to this particular file that you are talking about? B1, B2? No, tell me whether they will send or not. When they are not sending, name node will understand, okay, when it comes to file F, it is only two blocks. And the two blocks are present in S1 and S2. Then why I have to send the code to S3 and S4?
So the heartbeat has the information that the files is residing in the block.
That is what it has to hold. No, what other information a heartbeat signal will have? Heartbeat, which we have discussed very initially itself, a heartbeat signal will contain detail. I'm alive. I'm holding the blocks, say B1, B2 of file F. So see, that is the main reason a heartbeat signal. No, otherwise a heartbeat signal cannot carry any value. Right? Fine. Yes. There is a question on the chat. How outputs are consolidated and processing time of each node is different, and in Python against all nodes increase the cost factor compared to the master having the knowledge. Processing something like standard for relational. No, the time when the consolidation happens purely depends only after all the data node has finished their intermediate output generation. See, I cannot do the consolidation when another data node is still processing my file, right? So consolidation only begins after all the associated data nodes finished their intermediate output. You're not processing them in all the nodes. See, wherever I have the data, only that node is going to process it. Not every node is going to process. Wherever we have the particular data that needs to be processed, that is where the data is going to be processed. Will be automatically updated in the replicated. Not needed. No, see, replicated copies is needed only when your data is lost. There is no need for you to update it. At the final output is what you need. You don't have to maintain it on all the replicated copies. So it is not going to happen. It's not going to be automatically updated in the replicated copy. You're not changing the file. You're generating the output. Only if you are touching upon the file, replicated copies needs to be edited. You are generating output out of it. Why we need to touch upon the file, right?
So,
Fine, guys.
Sylvia,
Yeah.
just one last question. So, with regards to the Raghu's question only. So when the mapper, distributes all the tasks, equally to their data nodes. So at that point of time, suppose a task is distributed to, a task is handled by a first data node. The finish of that task will be it should be, or it must be the start of the task for data node 2, right?
Not needed, no. See, in a file, you have 1,000 lines. I'm
Uh,
processing the first 10 lines in the first node. I'm processing the next 10 lines in the next node. Now, within that first 10 lines, whatever data is there, that can be processed separately. The 11th to 20th line can be processed separately because at any day, you are going to combine the final output together. So there is no dependency between these two nodes. It's not, then it becomes sequential. There is no way of parallel processing there. No? You're getting my point?
uh, yeah, to somewhat extent. But
See,
my question is like, ki agar two data nodes are performing the same task, just in case, so doesn't it increase the what is the cost factor?
two data nodes are performing the same job, but then the data size is huge such that one data node cannot process it completely. No, that's the reason we are splitting them into two different data nodes. If one data node itself can handle that complete load, then we are not going to even divide it. So the first 10 lines I'm processing, I'm having the output. 11 to 20, I'm processing, I'm having the output. Then I'm going to consolidate both.
I think I wrongly put my question. So I thought that one, just like you gave the example. So first 10 lines are being processed by two data nodes and then they are consolidating each other.
That is also similar. So for example, line number 1 to 10, then you are splitting them from 1 to 5 in one block, to 10 in another block. Is it what you're saying? Is this what you're saying?
My question revolves more around like how the splitting factor is working.
How the splitting factor is working based on the block? You have file, right? How the splitting works? Based on the size of your file, the file gets divided into certain number of blocks. If your file is of, let's say, 10 MB is my block size, imagine the file is of 20 MB, the first 10 MB will be considered as block 1, second 10 MB will be considered as block 2. So that is clear?
Yeah.
So block 1, which is basically having line number 1 to 5 is residing inside this machine. 6 to 10, which is the next set of 10 MB is residing inside this machine. So is that clear?
Okay.
Now, processing this 1 to 5 and 6 to 10 can be parallelly done, right? Is there any dependency?
No.
Then what I can do? Process a block 1, get the output. Process a block 2, get the output. Combine them whenever needed. Make sense?
Yes.
Right? See, if at all there is a dependency, then there is no distributed processing itself because here I'm doing a parallel processing, which is what giving me the best and which is what making me call it as divide and conquer itself. If I wait for block 1 to generate its complete output, then only I'm going to generate, then it is as equal as a sequential process.
Correct.
Right? So this is how it's going to happen. There's no dependency between the blocks when it is generating the output, which makes it much faster.
Yeah.
Am I clear now?
Sylvia, I think to make things clear, I think we can take this way, right? The Python file we are giving is the one responsible for processing the data. That's not the data itself, right? That's a Python file is to process the data. So that will be distributed across the nodes, and the input file which we are intended to compute is distributed across the different compute nodes, right? I mean the node manager nodes, right? And then the Python file, yeah. So I think the confusion arises like maybe people think that the Python itself is a input or the one getting processed. So I think
see, because that's the reason we are talking about B1, B2. These are the blocks of reflex. PY is just a code which needs to be applied on top of this. This is your whole input. If in case anybody is taking it wrong, please remember this is a program. This is not the file. Imagine I'm writing a word count program. This is your program. For your word count, you're supplying a file. That file is divided into blocks. So
maybe a CSV file or whatever, right?
Yeah, it could be anything. Yeah, it could be a CSV, it could be an Excel, it could be any kind of DAT, JSON, any file it could be. The program is reading that file and process. File is only getting distributed. I believe when we when we finished HDFS workflow, all those was clear. So maybe if in case some of you are having a misconception, please be clear on this. So this is how we have to take it. Okay, I know it's a lot to take. It's surely a lot to take. So, but then you guys will slowly get comfortable with that. So, being the very first day, I know it's definitely a lot to grasp and a lot to take, but we are good. Going forward, we will learn few more stuffs, which makes your learning much more comfortable.
Yeah, Priya, I have one doubt. So suppose I have a 10 KB file and block size 120 to default is 128 MB, correct? So also
file of 10 KB and a block size of 120 MB. Okay.
Default size is 128 KB, correct? So it will also split in the multiple block. Yeah, it will keep only one file, one block.
One block only, because your file size is way lesser than a block size, no? Your file size is just in KB, but your block is in MB. So how much ever you need, that alone you will take. The remaining will be left off.
Okay. Okay.
That is called dynamic storage. Again, we discussed that in the session. Okay, great guys. So
sorry, Sylvia. Just before we close, I mean, the entire agenda of this course is to focus only on Spark, or we have any other topics to cover as well?
No, only it's all about Hadoop and Spark. Of course, Hadoop, most of areas, 90% I have completed now. But then MapReduce, we'll do a quick refresh tomorrow when we start, and then we will move on into Spark.
Okay, got it. Thanks.
And we'll have a small quiz tomorrow when we start the session. So I would encourage you guys to have a look on the slide before you turn up for tomorrow. So we'll just spend some 5 to 10 minutes on a little quiz just to check our understanding, and then we'll move forward.
Sure, thank you.
Fine. So there is a link which has been shared to me, a Google Drive link. I will share this slide that I have used in the class on that link, so you guys can take it.
Can you share that link with us?
Can
you share this?
Is it not shared with you guys already, like a class drive link or something?
It changes with the faculty. So
okay.
Can you share this in the chat if possible?
Yeah. Just give me a sec. I'll check. So hope today's session was useful. So what do you find? I guess the pace on which we are going is good. If you guys need any change, let me know. I know there is a lot to learn here in big data, so I'll try to cover as much as possible needed for you guys. So please do stop me if you feel the pace needs to be increased or decreased, so that I'll be doing accordingly. Can anyone please check whether this link is opening? Right now I haven't uploaded.
Yeah, it's opening.
It's opening, but there is no file. It's empty.
Yeah. I'll upload the slide that I have used today.
Okay.
Fine.
Would you be able to
anything-
upload that file today itself so that we can revise it?
Yeah. Post the session. I'll once I close the session, I'll upload.
Okay.
And I think we are good. We have passed the time. It's 12:10, so that's fine. Anything else, guys, before we wind up for today? So can everyone just gives a thumbs up if you find the pace is good? I know some of you said you're good, but then it would be great if I could get to see the count before you leave the session. Okay, so that's the reason I'm asking. If you feel this is a little faster or a little slower, you want me to speeden up, please do mention accordingly. And you can tell me at any point of time. Great. Okay, great. Thank you, guys. Hope today's session was useful. Let's see you back again tomorrow, same time. Thank you all. See you. Bye.
Thank you.
Thank you. Bye.
Thank you. Bye.